Okay, so tool tags. Now, there's nothing special about tool tags themselves, but it's the information that we put on the tool tags. Now, on these tags that we label ourselves, we tell the type of tool, basically what it is, an end mill, drill, that type of thing, and what material it's used for, whether it is for ferrous or non-ferrous, and then two critical dimensions, the diameter and the gauge length. Now, a lot of times we don't really think of gauge length. Now, what gauge length is a distance from a line here, and it's a theoretical line. It's not the top of the flange. It's actually right, maybe an 1/8 inch above the flange to the bottom of the tool. Now, once that gauge length is known, that is plugged into the control to tell it how much lower from the spindle gauge length to the bottom of the tool. That known number, you can use that and plug it in, and then you tell the machine the origin or the Z0 plane of your workpiece or your fixture. So if you had a gauge length in your control, a tool gauge length of 0, and you went to Z0, it would take the spindle face and it would bury it onto the Z0 position of your fixture or your part. Obviously, you don't want that. So the tool gauge length offsets it up in Z. That being said, why does that matter? Well, once you go through the trouble of finding the gauge length of a tool, you've already done a lot of work. So by adding a tool tag that travels with the tool, that allows you to set up the same tool at a different machine or the same machine with a tool that's already been touched off at a later date. Now that process alone right there makes it so that you're not redoing work. You've already done the work. Now you've recorded it. Now that work doesn't need to be you're not putting yourself in a redundant position. And this is how you get overall setup time to be reduced. Tool tags, super simple. We make these labels on our Dymo label printer or on our tool presetter that just prints automatically.